Let's take a look at some applications involving the ideas about area and then also cycling back to how it relates to perimeter on a couple of figures. Now for the figures that we're looking at right now, we would just need to kind of know that we're going to be working with a bunch of rectangles. So if we want to find the area of a rectangle, its formula would be to multiply the length times the width of the rectangle, but to kind of see why, if I have a rectangle that is 4 inches by 2 inches, and I broke this up into little squares, so along this bottom row I would have 4 squares, each 1 inch by 1 inch, and then because it's 2 inches high I would have another row of squares. So to find the area of this, I could do 4 times 2. So I have 4 squares in each row times 2 rows, so that would give me 8 square inches. All right, so that connects to the formula for area of a rectangle, which is always to multiply its length times its width. So on this example, we want to find the area of this metal plate. So there's a couple ways that we could do this. Because this one already has the plate kind of sectioned off into little squares, I guess one way we could do it is we could just count the squares. Now that looks a little bit painful because there's lots and lots of little squares on here, but I will leave it as an exercise to you to go through and count all these little squares that are on this metal plate, and you should reach that there are 42 squares, where each square is going to be 1 inch by 1 inch, so we would say the area of this would be 42 square inches. And that is a method to answer this question because I can see all the little squares. But let's talk about some other ways to figure out the area of this metal plate or how many squares it would take to cover it. Now one of the ways of doing this is to maybe break this into pieces where I can find the area of kind of each sub-piece. Okay, so I'm going to say maybe method 2 is break into sub-pieces. So for instance, like this region over here on the right is being 3 inch right here by 8 inches down right here. Okay, so if I kind of chop this right there, just to find the area over here on this right-hand piece, this would be 3 times 8 or 24 square inches. Okay, so I'm just going to record that over here as part of one of my calculations. Alright, so that accounts for that. Now down here at the bottom, this 9 stretched from edge to edge. So I've already kind of accounted for a couple of those squares on this right piece that I found. But if I know that 9 stretches from edge to edge, right, so from here to here, but I've already accounted for 3 up here, then what must be left over in this region right here would be 9 minus 3, or 6 inches. All right, so if I have 6 inches from here to here, and then I can play this same game kind of to figure out how tall this region is. All right, so I got a lot of markings on here. Maybe I'll erase some of these. All right, so if I know that this is 8 along this entire side wall, but I've already accounted for 6 right here, then this region right here must be 8 minus 6, or I have 2 left over. All right, so this little piece right here is 2. And this little piece down here is, we found to be 9 minus 3, or 6. So for this rectangle right here, this is 2 times 6, or 12 square inches. I'll bring that over here into my work. So finally I have this little region over here. I know it's 1 inch across the top, and this length right here will match this length right here, which I was told was 6 inches. So this will be 1 times 6, or 6 inches. So adding 24 in the right region, plus 12 in this bottom region, plus 6 over here in this left region, gives me 42 square inches. So that's another way to do this problem. Perhaps a third way, I'm going to erase all these markings. And by the way, this is not the only way to break this into subpieces. There's lots of different ways that you could chop this up. Just method 2 is to break this into smaller pieces where you can find the area of each piece and you add them all together. But another way that you could do this, I'll call it method 3, is you could find the area of what I'm going to call the whole thing. And then subtract the area removed. Okay, so it just involves looking at the figure slightly differently. So what I mean by the whole thing is this whole thing. Imagine if we hadn't removed kind of that U bend in the middle. What would the area of this whole thing be? Well, this would be a 9 by 8 rectangle. So 9 times 8 is 72. That would be the area of the whole thing. But we removed this area right here, right? This was eventually kind of like cut out of this plate. So the piece that got removed has a length of 5 and a width of 6. So this guy's area would be 5 times 6, or 30. So 30 square inches is the piece that got removed. So if I started with 72 square inches and I removed 30 square inches, then I'll be left with 42 square inches. So just a different way of thinking about the figure. Let's move into one where we can't necessarily see the squares and we have to kind of think about it from another point of view. So very similar to kind of what we were just looking at. This has a kind of a U-bend shape where the sides are 9 centimeters across the left, 12 centimeters across the bottom, and then I have this upward piece that's not labeled. I have a 2 centimeter piece along the top right, and then it's going to come down to make a U. I have the lower piece and the piece to the left unlabeled, but if I come up, it's going to be 6 centimeters, and then it's 6 centimeters across the top to come back to where I started. We're going to find the perimeter and the area of the figure. So again, just to kind of contrast this, I have the same figure repeated. I'm going to mark over here on this left figure stuff relating to perimeter ideas, and over here on the right, I'll mark over here on the stuff relating to area ideas, just to kind of contrast. The distance around the outside edge is different than finding the amount of space inside. Alright, so for perimeter, if I walk around the outside edge of this figure, like for instance, if I grab this edge first, this would be 9. Walk across the bottom, that's 12. Now, if I come up to this side, this is unlabeled, but we're going to assume these are all right angles. So however long this was over here on the left will also be how long this is on the right. So if this was 9 centimeters over here, this will be 9 centimeters over here. All right, across the top is 2. All right, now the next thing I have is this downward piece that's unlabeled, but I know this piece over here is 6 centimeters. So again, assuming these are right angles, and this is 6 centimeters over here, this would be 6 centimeters over here. Okay, so coming down, I would have 6. Now the next piece I hit would be this guy. So how big is that? So here's where we're going to use the other pieces of information I was given. If I know that this is 12 centimeters from edge to edge, and up here on this top portion I've accounted for 6 right here and 2 right here. Across the top also has to be 12 centimeters. It has to match what's going on in the bottom. I've already accounted for across the top 6 plus 2, or 8 centimeters. Well, if that has to be 12 centimeters total, and I've already accounted for 8, that leaves 4 centimeters left. You can think about those 4 centimeters being up here, but it doesn't make any difference if I kind of drop it down. So this distance right here would be 4 centimeters. So we'll add that to our total. Coming up this side right here would be my other 6. And then coming across this top piece right here would be another 6. Alright, so if I walk around the outside edge of this figure and add up all of the numbers that I'm seeing along the way, I get that it's going to take me 54 centimeters to wrap around the outside edge of this figure. So that's the perimeter idea. So let's talk now about area. So for area, I want to find the amount of space inside of the figure. There's a couple different ways we could do it. We could do it where we break this up into sub-pieces and find the area of each piece, or we could try to approach it to maybe trying to find the area of the whole thing and subtracting out the piece that got removed. So maybe I'll show you both methods. So for this one, if I break it into sub-pieces, and again, there's a couple different ways we could break this apart, but we have to be able to use the measurements that we're given. Right here across the bottom, I'm seeing that there's 12 centimeters. If I maybe break this up right here and right here, I've got to be able to find this distance along the side. If it's 9 centimeters from top to bottom, and it's 6 centimeters from top to kind of this break point right here, 9 minus 6 is 3 centimeters. So that means this rectangle down here across the bottom would be 12 times 3, or 36 square centimeters. All right, so I can find the area of that piece. Now that only helps me if I can find the area of the other 2 remaining pieces. This piece over here would be 6 centimeters by 6 centimeters, so 6 times 6 is 36 square centimeters, so I was able to find that, so yay. And this piece right here is 2 centimeters. Now I don't have this down length labeled right here, but I do have it labeled right here, and they have to be the same length. So this right here has to be 6 centimeters going down. So this is going to be 2 times 6, or 12 square centimeters. So to find the area of this thing, we can add up all these little tiny measurements. So 36 plus another 36 plus 12 is 84 square centimeters. Right, so that's kind of that approach about breaking this into sub-pieces. If I wanted to take another approach, or another way to do this, is I could find the area of what I'm going to call the whole thing, and I'm going to subtract the area removed. So the whole thing would be if I were to find the area of this entire piece if this one region right here hadn't been extracted. So the whole thing would be 9 times 12, or 108 square centimeters. But I don't have the whole thing. I have this piece right here that was removed, right? So the removed piece right here, I know that it's 6 down, but then the question is, how far is this over? Well, that kind of relates to a number we found along with this perimeter idea. If I know it's 12 centimeters from edge to edge, and I've accounted for 6 right here and 2 right here, or 8 centimeters total up on top, 12 minus 8 is 4 centimeters left over right here. So this region right here would be 6 times 4, or 24 square centimeters. So if I had 108 total and I took away a 24 square centimeter piece, then that leaves me with 84 square centimeters. I'll make squares, and up here I had that should also be square centimeters. All right, so just 2 different ways of finding the area. Breaking this into sub-pieces, or finding the whole thing and taking away the piece that removed will tell me what was left.